So for this question, it's asking us to identify the chemical formula for our diphosphorus pentoxide. So the first step that we have to do is to determine what elements we're using to come up with the formula. So when given diphosphorus pentoxide, ignoring the prefix names di and penta, we know that we are given phosphorus, and that's just the element P on the periodic table, and also oxide. Oxide is just oxygen, so that's just O. And oxide is the same thing as oxygen because when they add a IDE at the end, it's just letting us know that the compound is made up of only two different elements. So now that we've determined the elements, we look at the prefix names di and penta. Now, as you guys can see in the chart given, these prefixes. Di means 2, penta means 5, mono means 1, deca means 10, and etc. So if you have diphosphorus, it just means that you have 2 phosphorus. So you just write P subscript 2, and pentaoxide means that you have 5 oxygen atoms. So you just write O subscript 5. So your formula will just be P2O5. So the question is asking how many total lone pairs of electrons are present in the molecule PH2Br. P is the central atom. So to answer this question, we first need to know what a lone pair is. A lone pair is a group of 2 electrons around an element that isn't connected to anything. So the first step is to draw a Lewis dot structure for the molecule. The first step to drawing a Lewis dot structure is to first count the total valence electrons. The total valence electron in this case is 14 because H has 1 valence electron since it's in the first column of the periodic table, and since there's 2 hydrogens, you do 1 times 2, which just gives you 2. Phosphorus has 5 valence electrons because it's in the 5th column of the periodic table, and Br has 7 since it's in the 7th column of the periodic table. Then you subtract the total number of valence electrons by the bonds connecting the elements, and the bonds are just the lines connecting each element together, and each of those lines holds 2 electrons. The third step is to give the octet of electrons to first the outer atoms and then the central atom. So in this problem, they tell us that P is the central atom, so you draw the atoms around P, connecting them with bonds. So each element needs to follow the octet rule in having 8 total electrons besides hydrogen and a couple other ones. So hydrogen does not follow the octet rule because it only needs 2 electrons and is called the duet rule. So since hydrogen already has 2 electrons because of the bond with phosphorus, whenever you connect them together. So you only give the 6 electrons to bromine, and you only give 6 because it already has 2 connecting it with phosphorus. And once you give 6 electrons to it, it will make 8. And once you do that, you will see that it has 8 electrons. So now you do 8 minus 6, as you can see in the left side of the calculation. That gives you 2 electrons that are left over. And as you guys can see, phosphorus only has 6 electrons right now, and it needs 8. So I gave those 2 electrons to phosphorus. So now to find the lone pairs, you look at the pairs in the structure that is not connected to another atom. As you guys can see, I circled all of the lone pairs in this molecule, and Br has 3 lone pairs because that's how many pairs of electrons are not connected to another atom, and phosphorus only has 1 lone pair since that's the only pair that's not connected to another atom. And once you add both together, 1 plus 3, you will get 4. So this problem has a total of 4 lone pairs.